next quandary, we have f of x equal to negative 3 over x plus 2 plus 1, and then g of x is equal to 2 to the power negative x, because that is very poorly graphically shown. Minus 4, g of x equal to 2 to the power negative x minus 4. Well, first things first, determine f of minus 3. Well, let's oblige. So f of minus 3 is just equal to minus 3 over, well, minus 3 is the value we're asked to calculate. So 2 plus 1, that is negative 1, so 3 plus 1 is equal to 4. So f of negative 3 is equal to 4. And for our second question, determine x if g of x is equal to 4. Well, that's a g of x, so let's just place it equal to 4. So 2 to the power negative x minus 4 being equal to 4. Well, we add 4 on both sides. That zeroes out, and we'll have 2 to the power negative x. So undo that, negative x being equal to 8 to the power negative x. Well, we can convert this into exponential form. That's just 2 to the power 3. Thusly, minus x is equal to 3, but we were asked for the x value, and that is equal to negative 3. Let's just underline our results. Write down the asymptotes of f. Well, again, we have a look at the p value over there and the q value over there. So, therefore, our vertical asymptote as equation x is equal to negative 2, and our horizontal asymptote as equation y is equal to 1. Remember, that's our p value and that's our q value from our standard form. They want the range of g. Well, the range of g is determined by this, as well as the shape, the a value being greater than 0 over here, which means this function is decreasing, which means it's coming down, but we'll have that as an asymptote. Now, in this case, obviously our asymptote needs to be negative, so we'll have some scenario like this. This is not accurate, this is just for the case of this. And in terms of range, we want to know where the graph exists, where its y values are. Its y values are obviously not beneath the asymptote. And where's that asymptote boundary or asymptotic boundary? It's at negative 4. Therefore, y needs to be greater than negative 4, and it also needs to be a member of the real values. So that's 4 for you. Okay, determine the x and y intercepts of f. If we have a look at that, for our x intercepts, of course, again we'll place y equal to 0, and then we'll have minus 3 over x plus 2 plus 1 equals 0, which means we just have minus 3 over x plus 2 equal to negative 1. You cross multiply that, and we'll have minus x minus 2 equal to negative 3. Simplifying that, just add 2 on both sides. We get negative 1, of course, because that zeroes out. Thusly, x is equal to 1. So that x-intercept takes the form 1 and 0. For our y-intercept, we just place x equal to 0, which leads us to y being equal to minus 3. Well, x's value is 0, and then we add 2 plus 1, and that's minus 3 over 2. Well, 1 is just gonna, we can convert that into 2 over 2, so that's minus a half, which gives us the intercept 0 and negative 1 over 2. Well, determine the equation of the axis of symmetry of f which has a negative gradient. Leave your answer in the form y is equal to mx plus c. Well, we know from theory then that for the negative axis of symmetry we have a gradient of -1, because that equation always takes the form y is equal to -x plus c. And to complete the theoretical part, for the positive one we'll have a gradient of +1, which means we have y is equal to x plus c. Of course, in this case that is what we select, so we know that y is equal to -x plus c. How do we determine the specific equation? Well, if we have a look at any hyperbola, the axis of symmetry intersects at the same point where the asymptotes intersect. So that point where the asymptote intersects exists on both lines of symmetry, or both axes of symmetry, which means we can take that point. Now what is that point? Well, we do have the coordinates. We can take them from the equation, because we know that the x value is equal to -2, as we have over there, right over there, and then the y value is equal to 1. So that's what we use to substitute. So let's do that now. So the y value was 1, and the x value was -2 plus c. So that just simplifies to +2, and we need to subtract that on both sides. So that will be -1, which is the value of c, which is what we need. Therefore the equation is equal to -x minus 1, which is in the required form, of course. Well, as we can see, we need to sketch the graphs of f and g on the same system of axes, clearly showing all intercepts with the axes, I should say, and any asymptotes. Well, let's have a look. What do we have? We have a vertical asymptote at -2, so let's sketch that in. So that's x equal to -2. Our horizontal asymptote goes across like that, so that's y being equal to 1. Of course, again taken from there. Then we can sketch in the asymptote for our exponential graph, which just does that over there, and we know that that's y is equal to -4, of course. Well, of course, what other information we need? We need an x and y asymptote over there, not x and y intercepts over there. So let's quickly get them. For the y-intercept, we just place x equal to 0, so we'll have y being equal to 2 to the power -0 minus 4, which is just equal to, well, that's equal to 1, and 1 minus 4 is equal to -3. So we know where that sits. This is -2, go again by half, so let's just see how my measurement sits. So that's -3, of course. And then we need a y-intercept for it. Well, for that we have a y-intercept, which is equal to -3, which will say will sit comfortably over there. That's -3. And for the x-intercept, we place y equal to 0, so we'll just have 2 to the power -x minus 4 will equal to 0, so 2 to the power -x is equal to 4, so 2 to the power -x is just equal to 2 squared, therefore x will equal -2, which sits right over there. Let's use another color, and we know then because our x is negative over here, our x parameter, this graph needs to be decreasing, and as we can see, it is going to decrease towards the asymptote over there. Obviously needs to cut through the x-axis, -2, and then increase towards infinity in the y direction. So there we go. Hopefully that does it. And then as far as our hyperbola goes, well, we have its critical values. Its x intercept would sit right at 1. So that's going to be over there, the 1 and 0. And its y-intercept sits at -12, which again then is just over here, -12. So that's -1/2. And our a value is negative, which means we're going to use those two quadrants, which makes sense in terms of our asymptotes as well as the intercepts that we are or have calculated there. And that's a pretty neat curve, not too bad, not perfect by any stretch of the imagination. And then we just fill in a curve in our quadrant over there. Make sure all your critical values, the intercepts of course, as well as our asymptotes are marked. Now, if it is given that f of -1 is equal to g of -1, determine the values of x for which g of x is greater than or equal to f of x. Well, so one thing we haven't done, we know that that is f, and of course the exponential graph is g. So what they are telling us here is that this value, where the graph's intercept is -1. That is what this indicates. Well, how do we use that? Well, what do they want? They want the values of x for which g of x, the exponential graph, is above in English, I'll put the inverted commas, the hyperbola. Well, that happens in two places. Well, what we can see over here is right over there. So that's a place where it cuts, and right over here. Okay. So right over there. That's where it's above, and that's where it's above. So these give us two values because we have -2 and then -1, which they gave us. So x is obviously greater than -2, and we can't say equal to, even though that's what it's being asked. Let's remember that's an asymptote and no values over there make sense. And then obviously we can say less than or equal to -1. But we haven't calculated that value, so I don't see that as being part of our answer. Feel free to correct me in the comments if I am wrong, or if I just don't see it, because sometimes you don't see stuff.